All right, so today's notes are a continuation of the last time, still target 3. Today we are converting rectangular equations into polar equations. Last time we started with polar and went to rectangular. The basics of these that we talked about last time are going to be exactly the same though. We know that x squared, let me write here, x squared plus y squared is going to equal r squared. We know that x is equal to r times the cosine of theta, and we know that y equals r times the sine of theta. So we're going to basically be using the same things, just going the other way around. So we're going to start off with y equals 5. So y equals 5 we know is a horizontal line. Now this one, reasonably speaking, putting it into polar might be making it more complicated. We actually did this one the other way around on our last notes, but really one of the reasons that we will be doing some of these, a couple of these starting off a little bit easier, then getting maybe a little bit more complicated. Next year in calculus, you might have to take some of these rectangular, put them into polar because it actually makes it simpler to do some of the different calculus things with them. So that's why we're going through this here. So looking at the first one, like I said, we actually did this one the other way around on our last notes. So if I have just a singular y, like a y by itself, or just, any kind of y in there, I know I can look at the y equals r sine of theta. So if I have r sine of theta, if I replace the y with that, and that equals 5, we're basically almost done. However, when we write our polar equations, we do always think about them as being either r equals or r squared equals. So that's going to be kind of our ultimate goal on these, is to get it just r equals or r squared equals. So we're going to divide both sides by the sine. So 5 divided by the sine of theta. And essentially this is it. However, typically we want to try and rewrite them into maybe a little bit nicer of a form here. So instead of writing it this way, if I think about this, hopefully we can agree that this is really exactly the same thing, right? 5 times 1 over the sine. So really, we know 1 over the sine is the cosecant. So this is r equals 5 times the cosecant of theta. If you refer back to your notes from the other day, you'll see we started with r equals 5 cosecant theta, and we got it into y equals 5. So just kind of going the other way around here. So looking at number 2, our example. So again, notice we have an x and we have a y. So those are easy to replace. We're going to replace the x with an r cosine theta. We're going to replace the y with an r sine of theta. So again, we want to get this back into like kind of our regular polar form. So that means we really want to solve for r. Conveniently on the left-hand side though, both of these terms have a common factor of r. Don't forget about GCF. So if I take the r out of both of them, I get this left over. And really just to solve for r, I'll put that parentheses there, really just to solve for r, we would divide both sides by that 2 cosine theta plus 5 sine of theta. So we end up getting r equals 12 divided by 2 cosine theta plus 5 sine theta. Now this one we can't split up anymore. Because we have a sum in that denominator, I can't write it as like 12 over one and 12 over the other. It doesn't work that way because the sum is in the denominator. So that's it. This is our final answer for that one. That's the polar form. All right, one more. So looking at number 3, there actually are a couple ways you could do this. First, before we even start it, I want you to kind of look at the form that this is in. If you look at it, this is actually a circle. If we think about it, we have the x minus 6 and the y minus 8. That really means that it's a circle centered at the point 6, 8. Then think about like the h and k. And it actually also has a radius of 10. So it's just kind of something good to kind of think about in your mind. You don't need to do that beforehand. But that can kind of help you think about what you should be getting in the end of this one here. So there's a couple ways to do this. You could replace the x and y right away in here. However, I'm going to give you a little hint that it's generally a little bit easier to multiply things out first. It makes it a little bit easier because if you multiply it out, you're going to get an x squared and you're going to get a y squared. And we have some things that we know that deals with an x squared and a y squared in there. So again, you could replace it, but then you're going to get an r squared and a sine squared and a cosine squared. Again, there are ways you can go about it. I can show that as well. But typically we find it a little bit easier to multiply it out first in rectangular. So that means I'm going to square this. That's an x plus 36, and then square the y minus 8, so y squared minus the 16y plus 64, and that equals 100. So I'm going to kind of rearrange some things. I have an x squared and a y squared. Just for the sake of looking at this, I'm going to rearrange them. We have a minus 12x also, and we have a minus 16y. And then take a look at the numbers. We have a positive 36 and a positive 64. That gets us to 100. We also have a 100 on the other side, so if we subtract it, we get equals 0. So now let's start the polar things that we're going to be replacing it with. Hopefully you maybe recognized the whole goal of that is now we have an x squared plus y squared. We can replace that with r squared. Now, minus 12x, so here we can replace it with 12 times r cosine theta. And then here we can replace the y with an r sine theta. So it looks kind of complicated here, but one thing I want you to recognize is that all three of these terms have a common factor of r. Notice also it equals 0. So we're really thinking about it basically like a factoring here. So I'm going to solve it, or I'm sorry, I'm going to take out the r first, and then I'm going to think about solving it. So if I take out that r, again, if you think about solving this by factoring, normally you'd get r equals 0 as one of our solutions. Kind of think about this logically though. The r equals 0 as an equation would basically be just a point at the pole, right? If it has no radius, the radius is 0, it would just be a point at the pole. Is this equation just an equation with a point at the pole? No, right? We know that's a circle centered at 6, 8 with a radius of 10. So generally speaking, r equals 0 is not going to work. R can't equal 0. It's just kind of an extra factor of r in there. So that means I have that r minus 12 cosine theta minus 16 sine theta is equal to 0. And from here, we just want to get the r by itself, so that means r equals positive 12 cosine of theta plus 16 sine theta. And that is it. That is our polar equation. So work through these. Again, I can show if you want me to. I won't go through it in the video here, but I can show the other way of replacing it right away. Typically speaking, it's a little bit harder to do it that way, but it is possible. It's just usually a little bit easier to multiply them all the way out first. So try them in your homework. Some of them are really similar. Some of them make you think a little bit, but really it's just all about using those things to replace it in the polar. All right, let me know if there's questions. Bye.